Hi everyone, my name is Sarah Rogers, and today I'm going to be presenting on the lunging behavior in thin-shelled rock crabs. So again, my focal behavior is lunging. This video was taken in Kona, Hawaii in Kalikaua Bay, where I spent this term. These crabs are very good at camouflaging, so keep an eye out for the smaller crab directly below the larger crab. And here's the video. So as you can see, the smaller crab startles the larger crab, causing the larger crab to lunge away. Upon lunging, the smaller crab also exhibits this defensive technique and lunges in the opposite direction. So my causation hypothesis is neural responses in thin-shelled rock crabs triggered by environmental stimuli and perceived threats causes reflexive lunging behavior. In a study done on a different type of crab, the Chasmagnathus granulatus, scientists recorded neuron activity after predation stimuli and recorded escape behaviors from the crabs. So these recordings demonstrated that specific neurons responded to these visual triggers and caused these escape movements. My developmental hypothesis is thin-shelled rock crabs learn defensive behaviors such as lunging early in their lives as a result of increased predation during early development. So a study done on red king crabs showed increased behavior plasticity in juvenile crabs, and they wanted to study whether these defensive behaviors were innate or gained with life experience. So what they found was that juvenile red king crabs showed increased anti-predatory behavior in response to cues from predators. So basically this demonstrates that this lunging behavior, along with all other defensive behaviors, can be refined through experience with predators during the juvenile phase because of this behavioral plasticity. And this is a really important developmental skill to have in order to survive predation in adulthood. My functional hypothesis is the behavior of lunging away from threats increases the thin-shelled rock crab's chances of survival by creating substantial distance from predators or other crabs quickly and efficiently. The energy it takes to escape is less than fighting, as these crabs do not have strong fortified shells. So this article highlights defensive movements such as lunging, increases survival rates under pressure from predators. Basically corroborating that being able to escape quickly heightens the chances of survival, especially for crabs with thinner shells. My evolutionary hypothesis is the defensive lunging behavior of thin-shelled rock crabs is also shared with many other crustaceans, making it clear that this is an adaptation from a shared ancestor to avoid predation. And my article shows that a lot of different crustaceans have these defensive behaviors, meaning it's likely inherited an inherited behavior through a common ancestor. My relation to the Cogbook module of defensive behaviors, fleeing is an anti-predator adaptation. Lunging can be classified as fleeing. Thin-shelled rock crabs have evolved to sense threat or predation and respond accordingly. The behavior of lunging can be classified under the fleeing anti-predator adaptation. Here are my references. Thank you so much. I really enjoyed this class and observing crabs all semester.